All right, so this is going to be section 3.4, video number 2. We're going to continue our idea of knowing how to graph a sinusoidal curve. Again, that could be a sine or a cosine function, depending on what it is. So we're going to jump into an example here. We'll call this example 1 for our second video, where y is going to be -4 cosine of pi x and then -2. We haven't seen that one. We actually haven't done a cosine other than the standard one, and we haven't done one where we have something on the outside of the function being subtracted. So let's run through our pieces again. So we have an amplitude of 4. Again, the amplitude is always positive regardless of whether there's a negative sign. The negative is just going to flip it over. Let's see, we're going to need to figure out the period. The period will be 2 pi divided by the omega, which is pi. So that's 2. Again, we know it's going to be a reflection over the x-axis, and the -2 on the outside will actually be a vertical shift. So this will shift down 2 units. And that will also affect where our maximum and our minimum and our midline is going to be. So now let's go ahead and take a look at what this will look like, at least to start, and then we'll go ahead and sketch the graph. So we do know that the midline is now shifting down 2 units. So it usually is at the x-axis at 0. So our midline, which I'm just going to sketch here, is going to be shifted down 2 units. We know that the amplitude is 4, which means from the midline, it's got to go 4 units in either direction. So that means I'm going to have to go up from the midline, which is at -2, up to -1, 0, 1, 2. Your maximum is actually going to be up here. And the minimum, 1, 2, 3, 4 more units, which is kind of way down there off the graph there, is going to be down here. There was no period or phase shift. Again, we haven't dealt with that part of it yet. But everything you can see there did shift. Now, cosine typically starts at its maximum. But because of the fact that the negative is there, it's now going to start at its minimum. So basically on where the y-axis would be, that is your first key point. We still have 5. Cosine is one that's going to go from its max or its min through the midline to the other one, back through the midline, and then finish where it started. So out here, it's going to finish at its minimum. Now, according to this, this is going to have a period of 2. So that means that that is 2 units right there, which means in order to cut this thing into 4 equal pieces, 2 divided by 4 is 1/2. We're going to count by halves. So this should be 1/2, 1, 3/2, and then 2 on the axis. So let's see. Let's go with red to actually sketch this thing. We'll put our our min values there. It's got to hit its maximum now, halfway through, so that'll be at 1. And it's got to go through the midline halfway in between those two things. So that's going to be right here on the midline and right here on the midline. And remember, this is a curve. It kind of looks like it's a dome here, but it's not. It's really a curve, which is going to go like this, almost like a bell curve in this case. So that one had a lot of different pieces going on here. So that has now a amplitude of 4, again, 4 units from the midline to the max or the min. It's been reflected. So that means it's been flipped over, meaning it doesn't start at its max, it starts at its min instead. Everything has been shifted down 2 units, and it only has a period of 2, which takes the entire 2 units to get through 1 full cycle. So a lot of stuff happened right there on that particular problem. All right, for our second example, we're going to go backwards. I'm going to give you a graph in this case. We're going to take a look at what the graph would look like, and we're going to try and write a function based upon what we see on the graph. So I do have to kind of be a little bit more detailed in this. Let's say that that's 3, that's -3. We're going to say that this is 1/4, 1/2, 3/4, 1, and our graph looks something like this. Definitely not my best effort, but I think you can get the idea of what we're supposed to be doing there. So if this is the graph that it's given, and of course it's probably going to give much more of the graph than what you see here, because the graph obviously keeps on going. Technically, you could pick either a sine or a cosine curve because it is the sinusoidal curve, so could be either one. It's usually easiest, especially if you don't have any phase shifting going on here, which again, we haven't gotten to yet, to graph this based upon, does it start at its max or min, or does it start at its midline? If it starts on the midline, it's usually easier to call it a sine curve. If it starts at the max or min, it's usually easier to call it a cosine curve. And in this case, again, because we don't have any left or right shifting, I think it's easier to call this one a cosine curve since it starts at its maximum. So we're going to call this y equals some kind of a cosine curve. Again, I'm leaving some space because we have to make sure we take into account there could be an amplitude, there could be a reflection, there could be a different period, all that kind of stuff. So for right now, the easiest part to determine is we do have an amplitude other than 1 because it looks like it goes from the midline up to 3 and down to -3. So it looks like you've got an amplitude of 3. And it's not reflected because it did start at the maximum. It would start at the minimum, it would have been reflected. So now we got to figure out, how do we determine the period? Well, remember the period is determined by 2 pi over omega. Really what we need to solve for is the omega value. That's what we need. So if we want to solve that equation for omega, you would take omega and multiply it by your period, which would be 2 pi, and then to solve for omega, you would divide by the period. And that'll give us the value that we have to multiply times x in our cosine part. Oops, I don't know why I wrote a 2 there. It should be divided by the period. Okay, so now we have to figure out what is the period. Well, the period is how long it takes it to get through one full cycle, and looking at the graph, it goes from here out to here. That's one full cycle, and it looks like that value is 1. So I'm going to take omega and take 2 pi divided by the period, which means that omega is 2 pi. So when I go to plug this in, I'm going to put a 2 pi in front of my x. And it's not been shifted up or down, so there's no vertical shift, and again, no phase shift. So that would be an equation. Technically, we could have written this as a sinusoidal curve, but we really haven't learned how to do that yet because we haven't talked about the phase shifting. That is coming up right now. And unfortunately, if you remember in video 1, I used, I think it was C and D as part of the phase shifting and the vertical shifting. I just realized from looking through your book that it actually does use other variables. I do apologize. I'm going to write this out as your book would write it. I am probably going to continue to call them C and D. I just think it's easier. It's just, again, it's the way I did it. It doesn't make any difference what letters you put here. But they would have A times sine, again, it's omega x, which I have been using. They subtract, instead of C, they call it phi. It's another Greek letter. And then they actually add a capital B on the outside instead of D. So phi is basically my C. That capital B is basically my lowercase d. In any case, this is still your vertical shift. Vertical shift. And technically your phase shift, because again, you'd have to factor out the omega, would be, let me write this, phase shift would be phi divided by omega. When you factor that omega out, that's going to be your phase shift. So same idea. I will still probably continue to use C and D. So let's take a look at, and I'm probably not going to sketch these, but well, I'll probably sketch one of them, but I won't sketch all of them just because they take a little bit longer. Let's look at an example where we've got all that stuff. Let's see, what example are we on? Example 3. Oops. Okay, so example 3, we're going to have y equals 3 sine of 2x minus pi. Okay, so no vertical shift on this one. Again, we could put all those things together and put a vertical shift on there. I'll probably do one where we don't necessarily sketch the graph that has a vertical shift, but at least we can see all the different things that it would do. This one we will sketch. So let's see what we've got. We know we have an amplitude of 3. So from the midline, we're going to go up and down 3. We know that we need to find the period, which will be 2 pi divided by omega, which is 2. So the period here is pi. Now the phase shift, in order to do this correctly, we should probably rewrite this as 3 sine of, factor out the 2, which would then leave x minus, factoring out the 2 from the pi, leaves you with pi halves. And all of that in that bracket there is still part of the angle of sine. That tells me that I have a phase shift, right pi halves units, right pi halves, because remember, x minus is the equation, so really it's what's after the minus, which is pi halves, which is a positive pi halves because it's after the minus sign. Tells you that it's going to shift to the right pi halves units. And again, no vertical shift. So let's take a look at what this might look like. All right, so again, amplitude of 3, that's no problem. We'll go up and down 3 on the x-axis, excuse me, on the y-axis. And again, we're only interested in graphing one full period. We're not interested in continuing the graph, although once you do one, you can keep going, but just making sure you have at least one. The period is pi, which means it's going to take pi units to get through one period, but it does not start at 0 this time. It's going to start to the right pi halves. So I'm going to put my starting point at pi halves. Okay, it's sine, so it's going to start on its midline. Again, it hasn't been shifted up or down, so we're going to start it at the midline. Now I got to figure out, okay, the period is pi, which means if I want to go pi units from pi halves, I'm going to have to count by, because I got to put it in 4 equal sections, pi fourths. So again, I can put dots out here, that's no problem, or lines, excuse me, to separate this into 4 equal sections. Now we just got to figure out what they are. So if I'm going to count by pi fourths, so I got to add pi fourths to pi halves. But pi halves in terms of fourths is 2 pi fourths, right? So 2 pi fourths plus another pi fourths is going to give me 3 pi fourths. So the next place here is going to be 3 pi over 4. Adding another pi fourth to that is going to be 4 pi over 4, but that's just pi. Adding another pi fourths would be 5 pi over 4. And then adding another pi fourths would be 6 pi over 4, but that reduces to 3 pi halves. And then once again, what I know is that it starts at its midline, which is where we started it. Put that in blue. It will go up to the max because it has not been reflected, but the maximum is going to be up to 3 because of the amplitude, back down through its midline at pi, down to its minimum at 5 pi fourths, and that's going to be the y value of -3, and then finish back at the midline. So this is what your sinusoidal curve would look like that has been shifted. It's been shifted pi halves units to the right. And again, if you wanted to, obviously you would keep the curve going using the dots and so on. And then this way it would keep on going out that way and so on. So probably the easiest way to do that one. There are other ways. You could certainly figure out other ways to do it, but I think that's probably the easiest. All right, so now let's take a look at one where we're probably not actually going to graph it. I'm not going to sketch the graph of it, but let's at least figure out all the key pieces of information. Let's look at y equals 2 cosine of 4x plus 3 pi, all in that parentheses, plus 1. So we got a bunch of stuff going on here. As a matter of fact, the only thing that we don't really have, it looks like, is a reflection. So there's no negative sign out in front of your amplitude, so we don't have to reflect it. We got a bunch of stuff going on. So we do have an amplitude of 2. Okay, really the amplitude is probably the easiest thing to figure out with everything. I'm going to rewrite the function so that I have factored out what's in front of the x. And basically by dividing that 4 out of each piece on the inside, that's going to give me 3 pi over 4. And then I've still got a plus 1. So the amplitude is 2. The period is 2 pi divided by omega, which in this case is the 4. So that's going to reduce to pi over 2. So it's only going to take a period of pi halves to get through the cycle. It does have a phase shift. Now, because I have a plus sign right here, the phase shift is actually going to move to the left, because in order for that to be in the proper form of x minus, really that should be x minus -3 pi over 4, which means it's actually going to shift to the left 3 pi over 4 units. So this is going to shift left 3 pi over 4. And then it also has a vertical shift of 1 unit up. So the things that you would need to have here, so we know the amplitude, that's not too hard, but it did shift up 1 unit. So we know that the midline now is actually going to be at 1. So its maximum is going to be 2 above that, which would be at 3. Its minimum is going to be 2 below 1, which is going to be at -1. So when you were to graph that, you'd have to go up to 3 and down to -1. It's been shifted to the left 3 pi fourths units. So this thing is going to start to the left of the y-axis. May as well just at least do something on this. So here's 1. We know we've got to go up to 3. We've got to go down to -1 for the max and the min. It's going to shift to the left 3 pi over 4 units. And we have to figure out what we're counting by. So you take the period, divide it by 4, which is multiplying by 1/4. So you have to count by pi eighths. So 3 pi over 4 in terms of eighths would be 6 pi eighths. And remember, that's a negative, actually. I should have that there. So if we add a pi eighths to -6 pi eighths, we're now at -5 pi over 8. Erased it. -5 pi over 8. I did not leave myself enough room here. The next one would be -4 pi over 8, which is -pi halves. -pi halves, and so on. Really, this whole thing, I think, is going to fit on the left-hand side. I just did not sketch this out very well. So let me write this down here. You'd have the starting point at -3 pi fourths. Then you would have one at negative 5 pi eighths. Again, adding a pi eighths to that would be negative 4 pi eighths, which would be negative pi halves. Then adding one to that would be negative 3 pi eighths. And then adding one more pi eighths to that would be at negative 2 pi eighths, which is negative pi fourths. And then you would just basically sketch it through those 5 key values. And again, those would start on your midline. So like right here, then your 5th point, then your middle, and so on, something like that. But again, I did not sketch that very well, so I apologize. I probably shouldn't have even tried that. But those would be your 5 key points that you would be graphing. All right, I think that is plenty enough for this video, for these 2 videos. Quite a lot of stuff there, knowing how to do this. The nice thing is when you do this on the homework, it kind of lets you start sketching it. It draws the graph for you, and then you just have to know how to type in the shifting and everything and make sure it's all right. If you have a hard time with that, try and send me like an email or something like that, because sometimes looking at it or understanding it, the graph is not the easiest. And there is a little button that allows you to zoom in on the graph, because that'll be important when you have to actually look at a graph and write the function, because you need to be able to see the actual numbers to figure out like the period and stuff like that. But this is pretty important. It's really good that you understand how the graphs of sine and cosine work. The next section will focus a little bit more on tangent and the other 3. Not quite as we're not going to dive quite as deep into the other 3, but we will at least go through them and how they work.